So for this problem, we're asked to simplify the complex fraction before us. This is called a complex fraction because it looks like we have fractions that are comprising another fraction. What might help is to highlight the big fraction bar here. So because it feels like it's kind of too squished together, I'm going to go ahead and expand this out a little bit. By doing that, what I mean is I'm going to have my x squared minus w squared over x times w, and instead of having that big division bar, I'm going to switch it out for the division symbol. And then I'm going to follow that up with my x minus w all over w. From here, I can kind of harken back to what I know about dividing with fractions. So when I was kind of first beginning to teach, one person had presented it to me in the following way. We use this kind of like little, kind of trick where you say skip it, flip it, multiply. So in other words, we're going to skip our first fraction. In other words, we're going to leave it as we see it. We are going to flip the second fraction. In other words, we're going to take its reciprocal. So this time it's going to be w over x minus w. And this is going to change this to multiply. So because we have the x variable in here, I'm just going to use the multiplication dot. So the other thing that we might want to do is we want to break down the numerators or denominators if we're able to. Really, the only one that I'm seeing that we can do that with is the numerator in the first fraction. We have an x squared minus w squared. This is a difference of squares, meaning difference is referring to subtraction, and squares are referring to that each term, the x and the w, are both being squared. And this might be a trick that you'll kind of come across as you do more and more of these, if you haven't been able to recognize it quite yet. When we factor a difference of two squares, that will just produce their conjugates. So x plus w times the quantity x minus w. Or you might have written x minus w times the quantity of x plus w. So the order of that multiplication does not matter. That goes back to your commutative property for multiplication. Right underneath, we have x times w, and then the rest of our multiplication. So w over x minus w. What might help is you want to treat that x minus w in the denominator as one term or one value. So if it helps, I would encourage you to put parentheses around it just to kind of group it together. So we've done the heavy lifting here. We're just going to go ahead and see if we can cross cancel or cross reduce anything out. So I'm noticing that there is a single w in the denominator that will cancel out with the single w in the numerator. And then likewise, I see that there is an x minus w in the denominator and an x minus w in the numerator. So what's left? Well, first I'm going to create a little bit more space for myself. So what's left is we have x plus w. You can put those grouping symbols around if you would like. If you forget them, it's not a big deal. And then we have x in the bottom. So the one thing that I want us to note here, this is our final solution. We cannot clean anything else up. But let me take a moment and kind of show you a common error that sometimes people can make. So what some people would like to do would say, oh, I see an x down here and an x up here. I'm going to go ahead and cancel them. This would be incorrect. You're kind of reducing only a part of the number. The only way that you are able to maybe get rid of that x is if each term has an x in it. So let me show you what that would look like. So say that you had an answer where it was x plus w times x all over x. So notice that I have just one term on the bottom in the denominator, and then I have two terms in the numerator. Notice that each one has an x in there. So that's what would allow me to come through and say I'm allowed to divide out an x from every place which in this case would just leave me with 1 plus w. But again, if we go back to our final answer that I have circled, I do have an x in this spot, I do have an x in this spot, but I don't have an x in this spot, which prevents me from reducing an x out overall. This is why what I have circled is my final answer.